Limit root x minus 3 divided by x minus 9 as x approaches 9. Method 1. Limit of the function root x minus 3 divided by x minus 9 as x approaches 9 is equal to limit root x minus 3 divided by, writing the denominator as product of root x minus 3 and root x plus 3 as x approaches 9, and cancelling out the common factor root x minus 3, we have limit of the function 1 over root x plus 3 as x approaches 9 equals to 1/6. In method 2, we rationalize the numerator by multiplying the numerator and denominator with the conjugate of the numerator, which is root x plus 3. The limit becomes root x minus 3 times root x plus 3 divided by x minus 9 times root x plus 3 as x approaches 9. The numerator is in the form a minus b times a plus b, which is a squared minus b squared. This becomes root x squared minus 9, which is x minus 9, divided by x minus 9 times root x plus 3 as x approaches 9. Cancelling out the common factor x minus 9, we have limit of the function 1 over root x plus 3 as x approaches 9 equals to 1/6. Limit of the function x squared minus x minus 2 divided by 2x squared plus 1 as x approaches infinity. Limit of the rational function as x approaches infinity is the limit of the leading terms of numerator and denominator of the rational function as x approaches infinity. This gives limit x squared, which is the leading term of the numerator, divided by 2x squared, which is the leading term of the denominator as x approaches infinity. This gives us 1 over 2 by cancelling out x squared. Limit x minus 5x cubed divided by 6x squared minus x plus 1 as x approaches infinity is equal to limit of the leading term of the numerator, which is negative 5x cubed, divided by the leading term of the denominator, which is 6x squared, as x approaches infinity. Cancelling out the common factors in x, we have limit negative 5x divided by 6 as x approaches infinity is equal to negative infinity due to the negative sign of this number. Limit root x plus 1 minus root x as x approaches infinity. Rewriting this limit as limit root x plus 1 minus root x divided by 1 as x approaches infinity, and rationalizing the numerator, we obtain limit root x plus 1 minus root x times root x plus 1 plus root x divided by root x plus 1 plus root x as x approaches infinity. The numerator becomes x plus 1 minus x. And the denominator is root x plus 1 plus root x. Cancelling out the x in the numerator, we have limit 1 over root x plus 1 plus root x as x approaches infinity is equal to 0. Find the value of b such that the limit exists, and hence find the limit. Since the limit of the denominator as x approaches 2 is equal to 0 when x equals to 2 is plugged into x squared plus 2x minus 8, the numerator also must be 0 because the limit value of this function exists. So plugging in x equals to 2 in the numerator, which is x squared plus bx minus 6, should give us a value equals to 0, which means 2 squared plus b times 2 minus 6 equals to 0, which means b equals to 1. Therefore, the limit x squared plus bx minus 6 divided by x squared plus 2x minus 8 as x approaches 2 is limit x squared plus 1x minus 6 divided by x squared plus 2x minus 8 as x approaches 2. Limit of x squared plus x minus 6 divided by x squared plus 2x minus 8 as x approaches 2 is equal to limit, writing the numerator and denominator in fully factored form, we obtain x squared plus x minus 6 is x minus 2 times x plus 3, and x squared plus 2x minus 8 is x minus 2 times x plus 4. Limit as x approaches 2. Cancelling out the common factor x minus 2, we have limit x plus 3 divided by x plus 4 as x approaches 2. This gives 5 divided by 6.